Problem 11. A resistance of 10 ohms is connected in series with two resistance each of 15 ohm arranged in parallel. What resistance must be shunted across this parallel combination so that the total current shall be 1.5 amps and 20 volts applied, that is supply voltage is 20 volts. So this is the figure. So as we can see here, three resistance are in parallel and this combination of three resistance are in series with another resistance with 10 ohms. They have given supply current that is 1.5 ohms and supply voltage that is 20 volts. So they are asking the value of R, that is resistance which is parallel with this two resistance. So we know that supply current is 1.5 amps and the resistance which are in series is 10 ohms. So we know that the voltage across all the three resistance will be equal. So the supply voltage is 20 volts. Let us find the voltage across 10 ohm resistance. So we know the formula is equal to V is equal to R into I. So here I is 1.5 and R value is 10, nothing but 15 volts. So we got the voltage across 10 ohm resistance. So the voltage across this parallel resistance will be this resistance minus, this voltage minus this voltage. Therefore, VAB is equal to 20 minus 15. Therefore, the voltage of all across all these three resistance will be 5 volts. Now, we will calculate I1 and I2 using this voltage. I1 formula is nothing but V by R1. So, VE we found out that is 5 and R1 is 15. So, this is similar to I2. So, nothing but 1 by 3 that is given as here. So, both I1 and I2 we found out that is 1 by 3. Now, let us find I3. So, we know that I is equal to I1 plus I2 plus I3. So, therefore, I3 is equal to I minus I1 plus I2. So, by simplifying this, we will get I1 as 5 by 6 amps. Now, we know I3 and V. So, we need to find out R3. So, R3 is equal to V by I3. V is 5. I is nothing but 5 by 6. So, this 5 cancels and this 6 goes up, therefore 6 ohms, that is given as 6 ohms. So, problem number 12, determine the value of R if the power dissipated in 10 ohm resistance is 40 watt for the circuit shown in 1.21. This is the figure 1.21. So, they are telling to find the value of R where the power across the 10 ohm resistance is 40 watt. So, we know the formula of power, P is equal to I square R. So, using this we can calculate the value of I as we know R. So, I square is equal to P by R. They have given power that is 40 and we know R value that is 10. We will get 4. So, by sending the square that side, the I value will become 2 amp. So, we got the current that is 2 amp. So, let us find the voltage across this resistance. Let us call V1 and let us call this voltage as V2. So, as we know the supply voltage is 50. So, let us calculate V1 is equal to 2 into 10, that is 20 volts. So, we got the value of 20 volts. So, the supply voltage is nothing but V is equal to V1 plus V2. We know V1 is 20 and we need to find out V2. So therefore V2 is equal to 30 volts. So if resistance are in parallel, then the voltage across each resistance will be equal. Therefore the voltage across R will be 30, the voltage across 40 ohms will be 30, the voltage across 80 ohms will be 30. So by this we can easily find out the value of I1, I2 and I3. We know the starting formula is nothing but I is equal to I1 plus I2 plus I3. So we need to find I1 is equal to V divided by R1, that is 30 divided by 80. So we got I1 value, that is 0.375 amps. Let us find out I2 in the same way. 30 divided by 40. So we got the value of, that is I2 0.75 amps. Now let us calculate I3. I3 is nothing but I minus I1 plus I2. So I1 is 2 and this total is 0.375 plus 0.75. So calculating this, we get I3 is equal to 0.875 amps. Using this, we can calculate the value of R, that is 30 divided by 0.875, nothing but 34.3 ohms. This is what it has given. Problem number 13. In the circuit shown, find the value of resistance R when the power consumed by the 12 ohm resistance is 36 watt. So here there are three resistance which are connected in parallel, and this combination resistance is connected to a resistance R in series. So here we have to find out the value of R. They have given the power across R1. So first let us find RAB, that is equivalent resistance. So as these three are connected in parallel, we will find the equivalent resistance across it. By calculating using the formula, we will get 6 ohms, that is 12 into 18 into 36 whole divided by 12 into 18 plus 18 into 36 plus 36 into 12. By simplifying that, we will get the value RAB is equal to 6 ohms. So we can also simplify the figure by this. So there are two resistors now which are connected in series with a supply voltage of 60 volts and the current I. So this is RAB with 6 ohms and R. We have to find out R value. So they have given the power across R1 as 36 watts. So we know the formula P is equal to V square divided by R. So as they have given for R1 resistance, we should have VAB whole square divided by R1. So that is nothing but VAB square divided by R1 value is nothing but 12. So power is 36. So 36 into 12 is equal to VAB square. So VAB square is nothing but 432. Now VAB will be square root of 432. That is nothing but 20.78 volts. So now we have got the voltage across point A and point B. Now let us find I1, I2 and I3 using this voltage. So I1 is equal to VAB divided by R1. I2 is VAB R2. I3 is VAB divided by R3. So we know the value of VAB and R1. Now calculating this, we will get 1.73 amps. Calculating this, we will get 1.15 amps. Calculating this, we will get 0.57 amps. So we will get the supply current by adding all the three, that is nothing but 3.45 amps. So this is the formula to calculate the supply current. Now let us find, in the question they have said that we have to find the resistance R. So now let us find, we got I is equal to 3.45 and voltage across this is nothing but 20.78. so this is V2 we have to find. So nothing but we have formula I is equal to V by R. So we know V is 60 and R is 6 plus R. R equivalent R. So if I put 6 plus R and 60 by 3.45, we will get, by simplifying this, 11.4 ohms. This is what? This is a simplification. The final answer is 11.4 ohms. So that is nothing but 11.4. Problem number 14. In the circuit shown in the figure 1.23, determine the current supplied by the 100 volt source and the voltage across 6 ohm resistor. So this is the circuit, this is the figure 1.23. So they are telling to find the supply current, that is I, and also the voltage across 6 ohm resistor. So first we need to find I. So that can be found out by the equivalent resistance. So first we need to find the equivalent resistance across this parallel resistance, that is 6 ohm and 3 ohm. That would be 2 ohm given here, and again this 2 ohm will be in series with 3 ohm and 5 ohm, which will be 10 ohm. So this 10 ohm, so this will be equal to 10 ohm, and this 10 ohm will be in parallel with this 10 ohm, which equivalent will be 5 ohms, and this 5 ohms will be in series with this 5 ohm, making the circuit so this will be equal to 5 ohm, and this will be equal to 10 ohm. This 10 ohm will be in again parallel with this 10 ohm, making 5 ohm, and that 5 ohm will be in series with this 5 ohm equivalent, making R equivalent is equal to 10 ohm. Using this we can find out I is equal to V by R equivalent, that is nothing but 100 divided by 10. So I is equal to 10 amp. So the first is the current supplied by the 100 source volt is nothing but 10 amps. So next we have to find the voltage across the 6 ohm resistance. So this is the 6 ohm resistance. So we know current is 10 amps. So then the current will start dividing here. As we know, this part is 10 ohms and the other another parallel resistance is 10 ohms. So the current will divide equally. So this will be 5 amps, this will be 5 amps, and again the current at the point B will divide. So as we know, this part is 10 ohms and this resistance is 10 ohms. So again the current will divide equally. So here it is 5 amps, so it will be 2.5 amps, and here it will be 2.5 amps. So I'll write this this parallel resistance here. So this 6 ohm and this 3 ohm. So this is 6 ohm. So this is 3 ohm. So the current coming here is 2.5 amps. So let us take this is I1 and this is I2. So here you can see the ratio. Here the current will divide according to the value of resistance. So according to this ratio, the current here, so we can see the ratio is nothing but 3:6. This is 3 ohms and 6 ohms, that is nothing but 1:2. So the current here will be of 1/3 and here it will be 2/3. So using this ratio we can calculate. So let us calculate the current I1 here, that is current 2.5 into the ratio. So we are calculating across 6 ohms, that is the ratio is 1/3. So 1 divided by 3, 2.5 by 3, and again current 2 is equal to 2.5, 2 divided by 3, being what 5/3. So we should find the voltage across 6 ohm resistance. V 6 ohm is equal to I1 into, we know that 6 ohm, so nothing but 2.5 by 3 into 6 is nothing but 5 ohms, 5 volts. So voltage across 6 ohm is nothing but 5 volts. Problem number 15. In the circuit given below, figure 1.27, find the value of DC current through RL by using the Kirchhoff's law. There are two Kirchhoff law. One is current law and another is voltage law. Current law says that, so in any network of wires carrying current, the algebraic sum of all the currents meeting at a point is 0, or it can also be stated as the sum of incoming currents towards any point is equal to sum of outgoing currents away from that point. So that is current law. So if this is a point, if there are many incoming, so this is I1, this is I1, this is I2, this is I3, 5, 10 and 15, this will wind up as 30. So the outgoing should be 30 amps. So the value of incoming should be equal as outgoing, or at the point it should be 0. So at this, let us say it as A, so it should be 0. So the Kirchhoff voltage law states that the algebraic sum of all the EMF plus the algebraic sum of voltage drop is equal to 0. So that is EMF plus voltage drop is equal to 0. So here we will use the second law, that is Kirchhoff voltage law. So here we will first write the indication. So this will be plus minus according to the direction, plus minus. So we have given, so first, so we will take from this direction. Okay, so first we will have I1 R1, this is the Kirchhoff law, plus I1 I2 into RL, and as this direction is this, we are taking from this, it is minus, which is equal to 0. So this states that the algebraic sum of all the EMF, this is EMF EM, and sum plus the voltage drop is equal to 0. So substituting this, we know that R1 is 12 and I1 RL is 6 and E1 is 84. So we will get this equation. So we will take it as 1. So we have two supply E2 and E1. So again we will find out for E2. So here we will find out for E2. Again I'll write the indication plus minus and plus minus plus minus. So here we will write we will take from this direction. So later we took from here. So here, as this resistance will have a minus sign at the end, it will be like minus I1 plus I2 whole multiplied by RL minus I2 R2 and plus E2. So simplifying this, we will get the equation number 2. So taking into consideration equation 1 and equation 2, we will simplify. So this is equation 2, this is 1. So simplifying this, we will get I2 is equal to minus 1. So minus 1 indicates that the direction of the current flow is in the opposite direction as what we have assumed. So the negative sign of the current I2 means that it is flowing in the direction opposite to the. So here you can see the I2 is flowing from C to F, but actually it is flowing from F to C as it is negative sign. Here also it is flowing from D to E as it is negative. So then we will substitute I1 in any one of the equation. So we will take equation number 2 and substitute I1 and we will find out, substitute I2 and we will find out I1. So I1 is nothing but 5 amps. So later we can calculate I3. So that is the summation of I1 and I2. That is equal to 4 amps. So I3 flows in a direction assumed from D to C. So here we need to find the DC current through RL. So that is nothing but I3. We have found it as 4 amps.